Hello students. So in the previous class we have discussed already mathematical induction principle, and we discussed two problems in the last class, and I hope you are getting the idea a little bit, and in that step 1, step 2 are very clear, but step 3 little bit problematic for you people, and you will get little more practice is required. In today's class I will give some more idea how to solve those questions. So just we will look for next question. Just prove next question. Example number 4 you can take. Prove that 1 into 2 plus 2 into 3 plus 3 into 4 plus and so on plus n into n plus 1 is equal to n into n plus 1 into n plus 2 by 3. By using the principle of mathematical induction. By using the principle of mathematical induction. So just look for this question. Just we have to prove this by using the principle of mathematical induction. Just to take the statement, let us take phi of n. Phi of n is what? 1 into 2 plus 2 into 3 plus 3 into 4 plus and so on plus n into n plus 1. This is into dot 1.2, 2.3, 3.4 1 into 2, 2 into 3, 3 into 4 is equal to n into n plus 1 into n plus 2 divided by this 3. Let us take this is 1. The given statement is 1. So step 1 we have to take. So what happened, I said in the previous class there are 3 steps to solve the mathematical induction proof. So here how many terms? This is the first term. Look at this. This is the first term, second term, third term, fourth term, fifth term. This is the nth term. Be careful. Just be how to observe. Manipulate. Yes term is n terms, n number of terms. Just look at this. So just observe. Step 1, you know already. So we have to show it is true for n equal to 1. So for n equal to 1, just take down LHS. What is LHS? First term, n equal to 1 is 1 term. 1 into 2. 1 into 2 is equal to 2. So substitute n equal to 1 in RHS. n equal to 1, substitute here. 1 into 1 plus 1 into bracket 1 plus 2 by 3. So what happened? 3 gets cancelled. 1 plus 1 becomes 2. So both are same. So we can write as LHS is equal to RHS. Therefore, P of n is true for. Therefore, P of n is true for n is equal to 1. So next, step 2. Step 2. So in step 2, you know everyone, just observe. I don't want to discuss this step. Assume that P of n is true for some n is equal to k, where k belongs to some natural number. That is P of k. P of k, you know very well. 1 into 2 plus 2 into 3 plus 3 into 4 plus and so on plus k into k plus 1 is equal to k into k plus 1 into k plus 2 by 3. Let us take this is a 2 is true. Assume that P of k is true. Assume that P of k is true. Now we will move for step 3. What is the requirement for step 3? You know already. What is the requirement? You got the step 3 and n no. So the statement is true for n equal to k plus 1 also. We shall prove P of n is true for n equal to k plus 1 also. K plus 1 also. Just take this proof. Step 3 is very important. I said repeatedly in the last class. So just observe. We have to show that this is a true for n equal to k plus 1 also. So k plus 1 also we have to show. Just look at this. So consider only. So first, just consider this the kth term. Kth term type. Next term no. 1 into 2 plus 2 into 3 plus 3 into 4 plus and so on plus k into k plus 1 plus the next term ಏನಾಗುತ್ತೆ guess ಮಾಡಬಹುದು. Guess ಅಂದ್ರೆ n k ಇದ್ರೆ k plus 1 ಇದರ next term k plus 1 into k plus 2. I hope we will get it. This is the main point. ಸ್ವಲ್ಪ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಕೇಳಿ. ಒಂದನೇ ಟರ್ಮ್ ಫಸ್ಟ್ ಟರ್ಮ್ 1 into 2, ಸೆಕೆಂಡ್ ಟರ್ಮ್ 2 into 3, ಥರ್ಡ್ ಟರ್ಮ್ 3 into 4, ಹಂಗೆ ಫೋರ್ತ್ ಟರ್ಮ್ 4 into 5, ಸಿಕ್ಸ್ತ್ ಟರ್ಮ್ 6 into 7, 11th term 11 into 12, 100 into 101, nth term n into n plus 1, kth term k into k plus 1, hingare k plus 1th term k plus 1 into k plus 2. So this is the idea. So next we shall what we have to prove. Prove ಮಾಡಬೇಕು. If I simplify this, what is the requirement? n ಇದ್ದಲ್ಲಿ k plus 1 ಬರಬೇಕು. ನೋಡೋಣ. n ಇದ್ದಲ್ಲಿ k plus 1 ಬರಬೇಕು. ಏನಾಗುತ್ತೆ? n ಇದ್ದಲ್ಲಿ k plus 1 ಬರಬೇಕು. ಇಲ್ಲಿ n ಇದ್ದಲ್ಲಿ k plus 1 ಬರೆದ್ರೆ ಏನಾಗುತ್ತೆ? k plus 2 ಆಗುತ್ತೆ. n ಇದ್ದಲ್ಲಿ k plus 1 ಬರೆದ್ರೆ k plus 3 by 3. n ಇದ್ದಲ್ಲಿ k plus 1. So ಇಷ್ಟ ಆನ್ಸರ್ ಬರಬೇಕು. ನೋಡೋಣ. So just to take this from 2 I conclude it is true. It is nothing but from 2 I can write k into k plus 1 into k plus 2 divided by 3 plus this one keep the term as is, k plus 1 into k plus 2, because from 2 I have written this step. From 2 this is nothing but this. From second equation I can write this is nothing but k into k plus 1 by k plus 1 into k plus 2 by 2. So now what is simple idea? You know, in the previous class I did almost all we have to simplify in the sense taking the LCM. LCM ಏನಾಗುತ್ತೆ? LCM ಏನಾಗುತ್ತೆ? 3. So this is the k into k plus 1 into k plus 3 plus ಏನಿಲ್ಲ 1 ಇದೆ ಇಲ್ಲಿ 3 ಮಲ್ಟಿಪ್ಲೈ ಆಯಿತು 3 into k plus 1 into k plus 2. Okay. So what is common these two? K plus 1 common is outside bರುತ್ತೆ. K plus 1 and k plus 2. I am sorry. This is wrong. I did k plus 2 ಇದೆ. So k plus 2. K plus 1, k plus 2 common. So k plus 1 is common as well as k plus 2 is common. So what is left? In this term k is left plus in this term 3 is left. So divided by k patches. Oh my god, we got directly, no problem. No simplification required like last problem we did. So I can write in ಬರ್ಕೋಬಹುದು k plus 1, k plus 2 ಅನ್ನು k plus 1 plus 1 ಅಂತ ಬರ್ಕೋಬಹುದು, k plus 3 ಅನ್ನು k plus 1 plus 2 ಅಂತ ಬರ್ಕೋಬಹುದು by 3. Just look at this. ಇಲ್ಲಿ k plus 1 ಟರ್ಮ್ ಬರ್ದಿ. ಸೊ n ಇದ್ದಲ್ಲಿ k plus 1 ಬಂದಿದೆ, n plus 1 k plus 1 plus 1, n plus 2 k plus 1 plus 2. So n is replaced by k plus 1. Therefore I can conclude phi of n is true for n is equal to k plus 1 also. Hence by principle of mathematical induction, phi of n is true for all n. That is an absolute percent. It belongs to n. So what happened? This means the conclusion is over, and I repeatedly say that step 3 is making a very important rule. To understand this idea, just keep the point. ನಿಮಗೆ ಅರ್ಥ ಆಗತ್ತೆ ಅನ್ಕೊಂಡಿನಿ. ಯಾಕಂದರೆ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ಗೆ ಸ್ವಲ್ಪ ನಿಮ್ಗೆ ರೀಪ್ಲೇಸ್ ಐಡಿಯಾ ಬಂದಿರ್ತೈತಿ. ಇನ್ನೊಂದು ಯಾರು ನೋಡೋಣ ಪರ್ಫೆಕ್ಟ್ ಐಡಿಯಾ ಬಂದೇ ಬರ್ತೈತಿ. ಡೆಫಿನೆಟ್ಲಿ ಯು ವಿಲ್ ಗೆಟ್ ಕ್ಲಿಯರ್ ಐಡಿಯಾ. ಸೊ ಐ ಹೋಪ್ ಐ ಡೋಂಟ್ ವಾಂಟ್ ಟು ಡಿಸ್ಕಸ್ ಇಟ್ ಅಗೇನ್. So next problem, by practicing next problem you will get the clear idea. So this is our idea. Step 1 and ಏನು ಮಾಡಬೇಕು, for n equal to 1 you have to show it is true. Second step, assuming that the statement is true for n is equal to k, that is n equal to k means k is any positive integer or any some natural number. So in the step 3 what we have to do, step 3 ಅಲ್ಲಿ ಏನು ಮಾಡಬೇಕು, ಸೊ LHS ಅಲ್ಲಿ k plus 1 ಟರ್ಮ್ಸ್ ಅನ್ನು ತಗೊಂಡು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ. ಸೊ ಏನು ಬರಬೇಕಂದ್ರೆ n is replaced by k plus 1 in RHS of the given statement. So it is true for n equal to k plus 1 also. So next question, we will move to next question to understand the idea in brief way. Just prove by mathematical induction. The given question is like this: 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus and so on plus n into n plus 1 into n plus 2 is equal to n into n plus 1 into n plus 2 into n plus 3 by 4. Okay, I hope you will solve this question very easily. But step by step explanation ಕೊಡ್ತಾ ಹೋಗ್ತೀನಿ. So let us take proof. So before going to solve the proof, so let us take p of n. The given statement is p of n. 1 into 2 into 3. 1.2.3 ಅಲ್ಲ, 1 into 2 into 3. Second, 2 into 3 into 4. Third, 3 into 4 into 5 and so on, plus n into n plus 1 into n plus 2 is equal to n into n plus 1 into n plus 2 into n plus 3 by 4. Let us take this in 1. 1ನೇ term 1 into 2 into 3. 2ನೇ term 2 into 3 into 4. Third term 3 into 4 into 5. And here 10th term is 10 into 11 into 12. ಏನಪ್ಪಲ್ಲ ಹಂಗಿರ 10ನೇ term ಏನಂತತಿ 10 into 11 into 12. ಹಂಗಿರ 20th term 20 into 21 into 22. ಗೊತ್ತಿಲ್ಲ, ಸ್ವಲ್ಪ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾಗುತ್ತೆ. 100th term 100 into 101 into 102. So nth term n into n plus 1 into n plus 2. That is the key point. So next proof is required. Step 1. So LHS first term is equal to 1 and by bar 2. So first term is, this is the first term, second term, third term. So that's why LHS is what? 1 into 2 into 3. So 1 into 2 into 3 is 6. So just take down RHS and substitute n equal to 1. So n equal to 1 to very nice. 1 into 1 plus 1 into 1 plus 2 into 1 plus 3 by 4. What happened? 4 1s are 4 1s are 1 plus 3 4 right. So 1 plus 2 3 1 plus 1 2 3 into 2 6. It is also same as LHS, as we can conclude LHS is equal to RHS. Therefore we can conclude that P of n is true for n is equal to 1. Next, step 2. Assume that P of n is true for some n is equal to k. K is what? Any natural number. So that is P of k. P of k 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus and so on plus k into k plus 1 into k plus 2 is equal to another k ಬರುತ್ತೆ. So convert one k into k plus 1 into k plus 2 into k plus 3 by 4. Let us take this is a 2. I'm sorry. This is a 2. is true. Assume that it is true. Now what we have to do? Step 3 is very important. I am again saying that step 3 ನೀವು ಗೊತ್ತಾಗುತ್ತೆ ಸ್ವಲ್ಪ ಇನ್ ಬಿಡ್ಬೋದು ನೀವು ಸ್ವಲ್ಪ ಐಡಿಯಾ ಬಂದಿರ್ತದೆ. So as we are proceeding in the first class, first ಒಂದೇ ಪ್ರಾಬ್ಲಮ್ ಬಿಡಿಸ್ಬಿಟ್ಟು ಈ ಪ್ರಾಬ್ಲಮ್ ಡಿಫರೆನ್ಸ್ ಇದ್ದೇ ಇರ್ತದೆ. Just look at this. Yes, we shall show that phi of n is true for n is equal to k plus 1 also. There, that is consider ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ ನಾನು ಏನು ಬರಿಬಹುದು ಅಂತ. So first step you have to write the k plus 1 terms. 1 2 3 2 3 4 3 4 5 plus and so on. Kth term k into k plus 1 into k plus 2 plus ಇದರ next term ಏನಾಗುತ್ತೆ? The next term guess ಮಾಡಿ ಬರೀತೀನಿ. ಸ್ವಲ್ಪ guess ಮಾಡಿದ್ರೆ ಚಲೋ. 1ನೇ ಟರ್ಮ್ ಹೀಗಿದೆ, 2ನೇ ಟರ್ಮ್ ಹೀಗಿದೆ, 3ನೇ ಟರ್ಮ್ ಹೀಗಿದೆ, nth ಟರ್ಮ್ ಅಥವಾ kth ಟರ್ಮ್ ಹೀಗಿದೆ. ಇದರ next term ಏನಾಗುತ್ತೆ? ನಾನು ಬರ್ದಿರ್ತೀನಿ, guess ಮಾಡಿ ಇಟ್ಕೊಂಡು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. So this can be written as k plus 1 into k plus 2 into k plus 3. Okay, k plus 1 term. So next simplify ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ? In simplify ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ? So just concentrate here. Just replace n by k plus 1. So k plus 1 n ಇದನ್ನು k plus 1 ಬರೆದ್ರೆ ಏನಾಗ್ತದೆ? k plus 2 n ಇದನ್ನು k plus 1 ಬರೆದ್ರೆ k plus 3 n ಇದನ್ನು k plus 1 ಬರೆದ್ರೆ k plus 4 by 4 ಅಷ್ಟು ಬರುತ್ತೆ ಆನ್ಸರ್ 4. Simplify ಮಾಡೋಣ. So just this is a what? From equation number 2 it is true. Therefore I can write this is k into k plus 1 into k plus 2 into k plus 3 divided by 4 plus this term as it is k plus 1 k plus 2 k plus 3 because from 2 I have written this step from 2 this to 2. So simplify. For simplification take down the LCM. So 1 4 LCM of 1 and 4 is what? LCM of 1 and 4 is what? 4. So 4 ones are, so keep the term as it is. K into k plus 1 into k plus 2 into k plus 3 plus LCM 1 is under 4 batu. So 4 into k plus 1 k plus 2 k plus 3. What are the common terms? Take out side. So what are the common terms? K plus 1 is k plus 2 is k plus 3 term tagibbidu. So k plus 1 into k plus 2 into k plus 3. What left here? If you take this term common, k left here plus 4 left. If you take this common, 4 left. So k plus 4 divided by 4. So what is the requirement? ಬಂದರ್ ಟರ್ಮ್ಸ್ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಬೇಕಾಗುತ್ತೆ ನಾವು ಬರಂಗಿಲ್ಲ ಒಮ್ಮೆ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಬಿಡಿಸ್ತೀನಿ ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ ಬರಂಗಿಲ್ಲ ಅಂದ್ರೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಬೇಕು ಡೈರೆಕ್ಟ್ ಬಂದ್ಬಿಡುತ್ತೆ. ಸೊ ಜಸ್ಟ್ ವಿ ಕ್ಯಾನ್ ರೀರೈಟ್ k plus 1 k plus 2 ಅನ್ನ k plus 1 plus 1 k plus 3 ಅನ್ನ k plus 1 plus 2 k plus 4 ಅನ್ನ k plus 1 plus 3 by 4. So observe n इधर k plus 1 कांटिटी. So n into n plus 1 n plus 2 n plus 3. So n इधर in कांटिटी k plus 1. So what is our conclusion? Therefore phi of n is true for n is equal to k plus 1 also. Hence by principle of mathematical induction p of n is true for don't leave this step. If you are not writing this step, you will lose 1 mark. Just be careful. So you will lose 1 mark. Just carefully listen. Very compulsory. Not listen. Conclusion part. Most of the students will fail to write. Bala jana students ಬರೆಯೋದನ್ನ miss ಮಾಡಿಬಿಡ್ತಾರೆ. So ಮುಗಿದ ಪ್ರೂಫ್ ಬಂದ್ಬಿಡ್ತಾರೆ. ಹಾಗೆ ಮಾಡಬೇಡಿ. ನಾನು ಮಾರ್ಕ್ ಕಳ್ಕೊತೀನಿ. So just be careful. I am observing since from many years, most of the students will lose a mark in this step. So ಅಲ್ಲಿ ಎಲ್ಲರೂ ಬರ್ತದೆ ಕಾನ್ಫಿಡೆಂಟ್ ಬಿಟ್ಟು ಬಿಡ್ತಾರೆ ಲಾಸ್ಟಿಗೆ ಪ್ರೂಫ್. So ಅದಕ್ಕೆ 1 ಮಾರ್ಕ್ಸ್ ಹೋಗ್ಬಿಡ್ತೈತಿ. So ಅದಕ್ಕೆ ಹೇಳ್ತಿರೋದು ನಾನು ಸ್ಟ್ರೆಸ್ ಯಾಕೆ ಮಾಡೋದು. So if you are not writing your conclusion, they can cut 1 marks. So that's why you must ensure to write the conclusion. If I am not also mentioning here, ನಾನು ಬೋರ್ಡ್ ಮೇಲೆ ಸಾಲಾಗಿಲ್ಲ ಮುಂದಿನ ಪ್ರಾಬ್ಲಮ್ ಅದು ಬಿಡಿಸು ಅವಾಗ ನಾನು ಬರ್ದರೆ ಇಲ್ಲ. ಸೊ ಯಾವಾಗ ಬರೆಯಂಗಿಲ್ಲ, ಸೊ ಅವಾಗ ನೀವು ಬರ್ತಿರಬೇಕು. ಸೊ ಇಫ್ ಯು ಆರ್ ಲಿವಿಂಗ್ ಇನ್ ಎಕ್ಸಾಮ್ ಯು ವಿಲ್ ಲೂಸ್ 1 ಮಾರ್ಕ್ಸ್. ದಟ್ಸ್ ವೈ ಐ ಆಮ್ ಗಿವಿಂಗ್ ದ ಸ್ಟ್ರೆಸ್ ಫಾರ್ ಯು ಪೀಪಲ್. ಜಸ್ಟ್ ರಿಮೆಂಬರ್. ಸೊ ವಿ ವಿಲ್ ಮೂವ್ ಟು ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. Prove by mathematical induction 1 plus 3 plus 3 square plus and so on plus 3 raised to n minus 1 is equal to 3 raised to n minus 1 by 2. Note. So either just take the statement, let P of n, first term 1, second term 3, third term 3 square, fourth term 3 cube, fifth term 3 raised to 4, nth term 3 raised to n minus 1 is equal to 3 raised to n minus 1 by 2. Let us take it. Self observe ಮಾಡಿ. 3 raised to n minus 1 ಇದು ಬೇರೆ, 3 raised to n minus 1 ಎರಡು ಬೇರೆ. ಸೊ ಎರಡಕ್ಕೂ ಡಿಫರೆನ್ಸ್ ಇದೆ. ಸೊ ಯಾಕಂದ್ರೆ n equal to 2 ತಗೊಳ್ಬೇಕಾದ್ರೆ n equal to 2 ತಗೊಂಡ್ರೆ ಏನಾಗ್ತದೆ? 3 square minus 1 9 minus 1 8. So 3 raised to 2 minus 1 3, 2 minus 1 1, 3 raised to 1 ಅಂದ್ರೆ 3 ಆಗ್ತದೆ. ಡಿಫರೆನ್ಸ್. So that's why I am giving the idea. So this is totally different from this. 3 raised to n minus 1 ಬೇರೆ, 3 raised to n minus 1. So be careful. Both are different. So you just observe. ಇದು ಬೇರೆ ಇದೆ, ಇದು ಬೇರೆ ಇದೆ. ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ. ಆಮೇಲೆ ಒಂದು ಸ್ವಲ್ಪ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. 1 ಅನ್ನು ನೀವು 3 raised to 0 ಅಂತ ಬರ್ಕೊಂಡು 3 raised to 0, 3 raised to 1, 3 square, 3 cube, 3 raised to 4 and so on 3 raised to n minus 1. ನೋಡಿ ಇದು ಬಿಡಿಸುತ್ತಿದ್ದಾರೆ. ಇದನ್ನ ಎಷ್ಟನೇ ಟರ್ಮ್? ಫಸ್ಟ್ ಟರ್ಮ್. ಇದು ಎಷ್ಟನೇ ಟರ್ಮ್? ಸೆಕೆಂಡ್ ಟರ್ಮ್. ಇದು ಎಷ್ಟನೇ ಟರ್ಮ್? ಥರ್ಡ್ ಟರ್ಮ್. ಇದು ಫೋರ್ತ್ ಟರ್ಮ್. ಇದು ಫಿಫ್ತ್ ಟರ್ಮ್. ನೋಡಿ ಫಸ್ಟ್ ಟರ್ಮ್ 3 raised to 0, second term 3 raised to 1, third term 3 square, fourth 3 cube, fifth 3 raised to 4 and here 10th term ಯಾರಾದರೂ ಹೇಳ್ಬೋದಲ್ಲ 3 raised to 9. ಹಾಗಿದ್ರೆ nth term 3 raised to n. ಸೊ ಇದು ಗೊತ್ತಾದ್ರೆ ಸ್ಟೆಪ್ 3 ಈಸಿ ಆಗುತ್ತೆ. ಸ್ಟೆಪ್ 3 ಈಸಿ ಆಗುತ್ತೆ. ಸೊ 1ನೇ ಟರ್ಮ್ 3 raised to 0 ಅಂದ್ರೆ 3 raised to 0 ಅಂದ್ರೆ ಅಷ್ಟೇ. a raised to 0 ಅಂದ್ರೆ 1 ಹಂಗ. ಸೊ ನೋಡಿ so as usual the proof. Step 1, step 1 for n equal to 1. For n equal to 1, LHS is equal to 1, RHS n equal to 1 substitute. First term 1 ಬರುತ್ತೆ. RHS ನಲ್ಲಿ n equal to 1 2, 3 raised to 1 minus 1 by 2. So 3 minus 1 2, 2 by 2 is equal to 1. So as LHS is equal to RHS, therefore P of n is true for n equal to 1. So step 2, assume that P of n is true for n equal to k, where k is any natural number. So almost finishing. I don't want to discuss these things. That is phi of k ಇದೇನಿಲ್ಲ ನಾನು ಭಾಳ ಫಾಸ್ಟ್ ಬಿಡಿಸ್ತೀನಿ ಯಾಕಂದ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತಾಗಿದೆ 3 ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 3 ಕ್ಯೂಬ್ ಇಲ್ಲಾಂದ್ರೆ ಬರೀಬೋದು ಪ್ಲಸ್ 3 raised to k minus 1 is equal 3 raised to k minus 1 by 2 is true. So step 3 is very important, that's why I am giving the stress to this step only. I don't want to discuss that thing. So step 3, so consider first term 1, second term 3, third term 3 square, 3 cube and so on 3 raised to k minus 1 k term. And here next term 3 raised to k minus 1 ಅಂದ್ರೆ 3 raised to k ಅಷ್ಟೇ ಒಂದು ಕಡೆ ಮಾಡಿ k plus 1 ತರ ನಿಮ್ಗೆ ಗೊತ್ತಾಗಲ್ಲ ಅಂದ್ರೆ ಏನು ಮಾಡ್ರಿ ನಿಮ್ಗೆ ಯಾರಿಗೆ ಗೊತ್ತಾಗಲ್ಲ ಅಂದ್ರೆ ನೆನಪಿಟ್ಕೊಳ್ಳಿ ಇಲ್ಲಿ ಲಾಸ್ಟ್ ಟರ್ಮ್ ಅಂದ್ರೆ k plus 1 ಬರ್ಬೋದು ಏನಿದೆ ಯಾವಾಗ ಸೊ ಏನಿದೆ k plus 1 ಬರ್ಬೋದು ನೆಕ್ಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ನ ಕ್ಲಿಯರ್ ಐಡಿಯಾ ಸಿಗುತ್ತೆ. So this is nothing but a true from 2 I can write this is nothing but a 3 raised to k minus 1 by 2 plus this keep as it is. So ಇದು ಗೊತ್ತಾಗಬೇಕಂದ್ರೆ ಮೊದಲು ಎಲ್ಲರಿಗೂ ಇದು ಗೊತ್ತಿರಬೇಕು a raised to m into a raised to n is equal to a raised to m plus n. Law of indices, I hope you got that point. A raised to m into a raised to n is equal to a raised to m plus n. You know already. So LCM ಏನು 2 ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ 2 into 1 ಅಂದ್ರೆ 3 raised to k minus 1 plus 1 into 2 into 3 raised to k. ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಸ್ ಆಗಿ ಭಾಳ ಸಿಂಪಲ್ ಆಗಿ ಹೇಳ್ತೀನಿ. ಎಷ್ಟು ಅದಾವು ಏನು 3 raised to k a ಸ್ಕ್ವೇರ್ ಎಷ್ಟು ಆಕಾವು ಎರಡು ಗುಣಿಸಿದ್ರೆ ರೇಟ್ ಬರ್ತದೆ 2a ಸ್ಕ್ವೇರ್ ಬರ್ತದೆ a ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 3a ಸ್ಕ್ವೇರ್ ಎಷ್ಟು ಬರ್ತದೆ ಎಷ್ಟು ಬರ್ತದೆ 4a ಸ್ಕ್ವೇರ್ ಬರ್ತದೆ ಹಂಗೆ ಸಿಂಪಲ್ ಬೇಕು 3 raised to k 3 raised to k ಇಲ್ಲಿ ಯಾವ್ದವ ಇಲ್ಲಿ ಒಂದು ಐತಿ ಟೋಟಲ್ ಏಟ್ ಅದ 3 into 3 raised to k 3 ಅದ ಈ x 3x ಪ್ಲಸ್ x ಏನು ಬರ್ತದೆ 4x ಬರೀತಿಲ್ಲ ಹಂಗೆ ಅದು 3 raised to k ಏಟ್ ಅದಾವ ಯಾವ್ದವ ಇಲ್ಲಿ ಒಂದು ಭಾಳ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೊತೀರಿ ಸಿಂಪಲ್ ಐತೆ ಇದು ಒಂದ ಇದು ಯಾವ್ದು ಟೋಟಲ್ 3 3 raised to k ಅದ minus 1 ಗೆ minus 1 ಒಂದು ಬರೀಬೇಕು by 2. ಸೊ ನೋಡಿ ನಾ ಹೇಳಿದಲ್ಲ a raised to m into a raised to n equal to a raised to m plus n ಹೌದಾ. ಸೊ ಹಾಗಿದ್ರೆ ಇದೇನಿಲ್ಲ ಅಂದ್ರೆ 1 ಐತಿ. ಸೊ ಎರಡು ಕೂಡಿಸ್ಬಿಡ್ರಿ 3 raised to 1 plus k ಅಥವಾ k plus 1 minus 1 ಗೆ minus 1 by 2. ಏನು ಬಿಡಿಸಿದ್ವಿ ನಾವು ಏನು ಬಿಡಿಸ್ಬೇಕಾಗಿತ್ತು ಅದನ್ನ ಹೇಳಿಲ್ಲ ನಾನು ಇಲ್ಲಿ ಏನು ಬರಬೇಕಾಗಿತ್ತು n ಇದ್ದಲ್ಲಿ k plus 1 3 raised to k plus 1 minus 1 by 2 ಎಸ್ ನಾವು ಬೇಕಾಗಿದೆ ಸಿ ಹೌದು. ಸೊ therefore ಬರೀನ ಕನ್ಕ್ಲೂಷನ್ ನಾನು ಬರೆಯಂಗಿಲ್ಲ. ಓಕೆ therefore p of n is true for n equal to k plus 1 also, hence it is true for all natural numbers. So I hope you got the idea. Just very easiest way ಇದು ಹೆಂಗೆ ಐತೆ ಅಂತ ತೊಗೊಂಡ್ಬರ್ತೀನಿ. ಇದು ಟರ್ಮ್ ಯಾವ್ದು ಗೊತ್ತಾಗುತ್ತೆ ನಿಮ್ಗೆ ಗೊತ್ತಾಗಲಿಲ್ಲ ಅಂದರೆ ಆ ಲಾಸ್ಟ್ ಟರ್ಮ್ ತೊಗೊಂಡು n ಇದ್ದರೆ k plus 1 ಬರ್ತದೆ ಲಾಸ್ಟ್ ಟರ್ಮ್ 3 raised to n minus 1 ಐತಿ 3 raised to k plus 1 minus 1 1 ಕ್ಯಾನ್ಸಲ್ 3 raised to k ಗೊತ್ತಾಗ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ನಾಗ ಅಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ನಾಗ ನಾನು ಮತ್ತೊಂದು ಐಡಿಯಾ ಕೊಡ್ತೇನೆ ಅದರ ನೆಕ್ಸ್ಟ್ ಟರ್ಮ್ ಹೆಂಗೆ ಕಂಡುಹಿಡಿಯಬೇಕು. ಓಕೆ ಬಟ್ ಸ್ವಲ್ಪ ಐಡಿಯಾ ಬಂತು ನಿಮಗೀಗ ಈ ಲಾಸ್ಟ್ ಕ್ಲಾಸಿಗೆ ಈ ಕ್ಲಾಸಿಗೆ ಫರಕ್ ಆಗಿರ್ತದೆ ಸ್ವಲ್ಪ ಫರಕ್ ಅದು ಗೊತ್ತಾಗತೈತಿ ಸ್ವಲ್ಪ ಟೈಮ್ ಬೇಕು. ಓಕೆ ಸೊ ಐ ವಿಲ್ conclude my today's class by this question. In next class we will continue remaining problems till more practice is required. Thank you.